Course 3, Lesson 37 and 38. So first we'll look at some areas of combined polygons, being able to take some complex shapes and figure out what the area is by turning them into less complex shapes, basically splitting them up. So we could look at this trapezoid and say, sure, we remember the formula for a trapezoid, or we could split it into a rectangle and a triangle. So if we do that, we can take from this point right here, it's really wanting to be silly today as far as my pen on this board. Let's try it again. So we can split it down like that, and we can say, okay, well, this rectangle is 5 by 6, which means if that side is 5 there and it's 8 total on the bottom, well, then there's 3 left over for the side of this triangle, and the other side is 6. So to find the area of the rectangle, let's go there first. We would say, okay, rectangle is base times height, so we do 5 times 6 and get 30. And then we would say, okay, well, the triangle, I need to do base times height divided by 2, so 6 times 3 divided by 2. So that's 18 divided by 2, which is 9. So I need to combine 30 and 9. Sorry about all of these lines. Sometimes it just doesn't want to play nice. So we add together 30 and 9 to see that the area is 39 square units, square centimeters. 39 square centimeters for that one. Let's try another one. So we're going to take this one, cut it up just like we did on the last one. So we are once again going to have a triangle and a rectangle. So on this first one, it's 50 by 160. And if we look at this bottom piece, we need to figure out, well, what is the base of our triangle? Well, looks like there is 130. 130 left over for this triangle. I know it doesn't make a ton of sense as far as how it's proportioned. That's okay. By 160. So we need to do 50 times 160 plus 160 times 130 divided by 2. So if we do that, 50 times 160, we get 8,000. And if we do 60 times 130, 160 times 130, and then divide it by 2, we will get 10,400. And we need to add these together so that we get 18,400 centimeters squared. So split it up into less complex shapes so that you can say, I know how to find the area of this one shape and the area of the other. Let's look at this one. We have a couple triangles here that we can see. We can see a small one, AEB, and a big one, ADC. We're going to find out a bunch of things about this whole figure. So if we know that AD, that length is 40, all the way from here to here is 40, and let's see, we also know that DC down here is 30. We're going to assume that this is a right triangle. I'm going to say it is, which means I can find and use the Pythagorean theorem to figure out the hypotenuse of the big triangle, which means I'm going to do 30 squared plus 40 squared equals c squared. Now the other way you could see this is a form of the Pythagorean triple 3, 4, 5, which means if I have a 3, 4, 5 and I go to a 30, 40, 50, I really just multiplied everything by 10. So my big length AC from here to here is 50. Oh boy. Let's try that again. Okay. So we know AD is 40, AC is 50, and DC is 30. We're good to go there. It also tells us that point B is the midpoint of AC, which means if it's the midpoint, it splits it in half perfectly. So we get 25 on this side, 25 on this side. And point E is the midpoint of AD, which means I split 40 to be 20 and 20. Okay, Our goal is to find the perimeter and area. Let's find the perimeter and area of a bunch of things. First, let's find ADC. Find the perimeter and the area. Well, the perimeter is just going to be 30 plus 40 plus 50. Well, 30 plus 40 plus 50 is 120, and I think we are in centimeters. Yep. And the area, well, that means I'm going to do 30 times 40 divided by 2, so that gives me 600 centimeters squared. So that's a big triangle. Then we can look at the small triangle and say, okay, what is AEB? The perimeter and the area. Well, with that little one, I know most things about it, but I need to figure out, well, what is this base of the triangle? Well, that goes back to the Pythagorean theorem or our Pythagorean triple. And when we use either of those things, we see that it is 15. Which means when we add all of those up to get our perimeter, we're going to get 60 centimeters. And the area, 15 times 20 divided by 2, is 150 centimeters squared. Lastly, I want to find the perimeter and area of this weird trapezoid thing, EBCD. So the perimeter, I know actually everything that I need to. We have 30, 20, 15, and 25, which gives me a perimeter of 90 centimeters. The area, there's a couple ways to do it, and we could say, sure, we could cut it up and find the area of each of those pieces. Or we can say, well, that piece right there is really just the big triangle minus the small triangle. Okay, the 20, 15, 25 triangle. Which means I'm going to do 60 minus 150 to give me an area of 450 centimeters squared. Okay? And last example on this lesson. Find the area of this complex shape. Well, it looks to me like cutting off this triangle right here would be the best way to go. And so if I do that, that means I just need to find the area of one rectangle and one triangle. But I need to make sure that I'm using the correct dimensions, and I need the full length, full width of my rectangle, which means I need to use 12 and 6 to say that is my base and my height. So I do 12 times 6, which gives me 72. Let's say we're in centimeters. Then I'll need to add to that our triangle, which means, okay, what is the base and height of that triangle? Well, if this length right here is 8, and I know the full thing is 12, this must be 4. And if this long length is 10, and over here I have 6, well, that means that from here to here we have 6, so we need another 4 here. Which means I'm going to do 4 times 4 divided by 2, which gives me another 8 centimeters squared, giving me a total of 80 centimeters squared. All right, on to lesson 38. And we're going to say, okay, lesson 38 is using properties of equality to solve equations. Okay, this is pretty straightforward as far as we are using inverse operations to solve things. So with addition, subtraction, multiplication, division, we are going to undo what has happened to our variable to find our answer. So we'll just do a couple of these. So if we have 8s equals 72, that means I have taken s, multiplied by 8, and gotten 72. Well, to figure out what is s, I need to undo the multiplication, which its inverse is division. So I divide by 8 on each side to get s equals 9. I could continue with number 2 and say 4 times v, so I need to divide by 4 and get v equals 7. We can do that all the way across this page, dividing by what has been multiplied. Okay, just take a second, pause the video, and you can see why we have matched up these phrases with these equations. These are examples of multiplication problems that we can then solve. All right, let's look at this one. A hot air balloon flew at 10 miles per hour using the variable h. Write and solve a multiplication equation to find how many hours the balloon traveled if it covered a distance of 70 miles. So something equals those 70 miles. We would say, okay, the rate that they were going, rate times time equals distance. Okay, so rate times time equals our distance. So my rate is 10 miles per hour times, I don't know what my time is, okay? And they said, okay, use h for hours. So I have 10 times a certain amount of hours gives me 70. And to solve this, I would divide by 10. I see that it would take 7 hours to go 70 miles. Let's try some other ones. Now, instead of having multiplication problems here, we actually have division problems. So to undo those, I'm going to need to multiply. So in z divided by 1.8, since I divided by 1.8, I'm going to multiply by 1.8 on each side, which means that I get z is equal to 9. All right, let me just give some space, make sure that we can see everything. Okay, then we say p divided by 2 equals 9. Well, we divided by 2, so I multiply by 2. And I get p is equal to 18. 16 equals negative s. Now, you might look at this and say, well, isn't s alone, so aren't we done? I would say no. Technically, we have a multiplication or division problem here. We have a negative 1s, which means I have taken a negative 1 and multiplied it by s. So I need to divide by negative 1 to get rid of it. So I see that s is equal to negative 16. And lastly, h over 14 equals 25. Well, to get rid of that, I need to multiply by 14 on each side. So I do 25 times 14 and get h is 350. Okay, so just do the opposite of what you are seeing here. All right, after spending $2.30, Robert had $5.70. How much money did he have before he spent $2.30? Answer the equation to solve. Well, we would say if I have a certain amount of money minus the $2.30 and I now have $5.70, I could add my $2.30 and do the opposite operation and find my answer. Let me just get rid of this. Sorry about that. So I add $2.30 to each side, and I get that x is, well, $8. I had $8 to start with. Okay, let's try another one like this. If a 12-month subscription to a magazine costs $8.40, what is the average cost per month? So in a year, I'm going to spend $8.40 on this magazine. There are 12 months, and I get 12 magazines. So I would say, well, $8.40 divided by my 12 is going to equal my x. There's a lot of ways to do this problem, but we see that each issue is going to cost 70 cents. Okay, now let's try just a couple more examples here. We need to solve 2/3 w equals 3/4. So there's a couple ways to think about this. And first we can say, well, this is just multiplication. So I need to divide by 2/3 to get rid of it. Which means I have w equaling, well, if I'm dividing fractions, that's really just saying I'm going to copy 3/4 and multiply by the reciprocal. Okay, remember copy dot flip. So I get w equals 9/8. Other way that you could do this and say, well, I want 1w when I'm done with this. And the only way to do that is by multiplying by the reciprocal. You can see how these are very similar and get to the correct answer either way, which means that I get w equals, well, these cancel, and on the other side I get 5/12. All right. On all of these, just remember, you need to do the opposite operation. So on our first one, I need to multiply by 4. On the second one, I should add 2.3 to get x alone. In the third one, I need to subtract 1/2. And in the last one, I need to add 1.3. All right, last example. Last page. Peggy bought 5 pounds of oranges for $4.50. Solve the equation to find the price per pound. Well, as you can imagine, I have a certain amount of money I spend on each pound Okay, let's see, the price per pound, we'll represent it with a P, times my 5 pounds equals 450, which means I need to divide by 5 on either side to find that my price per pound is 90 cents. And the second one, from 8 a.m. to noon, the temperature rose 5 degrees rose 5 degrees to be at a temperature of 2 degrees. Solve the equation to find the temperature at 8. Well, what we're saying is I had a temperature, I added 5 degrees, and now I'm at 2 degrees. So to get to our original temperature, I'd subtract 5 and see that our original temperature is -3. Well, I hope this is helpful for studying and for homework.